because here there is an imaginary -1 in front. Or you can say the opposite of this, the opposite of this, or the opposite of that, whichever you prefer. It is wiser to consider a -1 in front. But there is no difference.
Okay, minus 112p
Yes.
squared
Yes.
minus 5/6p minus 5.
Excellent. By simply inspecting this visually, this polynomial, what degree do you think it has? Because that's where we have to start. We have to start with a degree always. The degree is
2.
2. Very good. Awesome. That's where we have to start.
Would you multiply 5/4 by 3/3?
Yes, because the least common denominator is 12, so you will multiply this by 3. So 15 minus 1 is 14, and we will have to simplify it in a minute. Good. Then, both are negative, so it's safe to write negative. If they were not both negative, then it wasn't safe to write anything, but they're both negative. And the least common denominator is
6.
very good. So again, we need a 3 up here. 9 and 5. Good. And finally, 6 minus 5, that is positive 1. It is a trinomial. It is in descending order. We have to simplify the fractions in front a little bit because we can. So this is 7/6p squared minus 7/3p plus 1. Don't touch this. This is it. There is nothing else we need to do here.
So where'd you get the -1 for the 15?
-1 for the 15.
For the 14/12. The first one.
Right here. So 3 times 5 is 15. That's okay. -1. Good. So one more evaluating. P of x is 6x squared minus 7x plus 3. Can anyone give us P of 0 quickly, without any calculations, really?
Just as is?
0, 0, 3. That's all I want you to see. 0, 0, 3. And what if we want to evaluate P at -2? I have to understand the pattern. And the pattern, again, is P of whatever equals 2 times whatever squared minus 7 times whatever plus 3. This is what I see when I look at this polynomial. So I have 6 quantity, parentheses mandatory, -2 squared, minus 7, parentheses mandatory, -2, and plus 3. Because this is a product and this is a product. So we need parentheses around -2 because -2 is a negative number. We have to follow the order of operations. We have to square first. Can anyone refresh our memory on -2 squared? How much is that?
24 or 4?
Very good. Now I can multiply -7 by -2 and I get 14. Now I go back to 24 plus 14.
Isn't it negative? Is it minus 14?
When I multiply a negative, that's okay, plus 3. Good. So 24 plus 14 is 38. 38 plus 3 is 41. Yes, very easy to put in the graphing calculator and double check. It takes a blink and it saves you points. So clear whatever you have. Careful how you enter it, 6x squared. And minus 7x plus 3. Since you already have this set up, it's already set up for second and table. You just have to enter 0 if you want to convince yourself that it's 3. And 4. No, I'm sorry, negative 2. And if the answer is not 41, I have to go back to my notes. I must have messed up something. Do not do this. Do not do this by hand, like 6 parentheses. No, 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 no. Because if you miss something, you will not get the correct answer. Always put it in y equals. You see it, you compare it, 6 times whatever squared minus 7 times whatever plus 3. Don't do this piece by piece. I'm not saying it's a mistake. I'm not saying you're not going to get the correct answer. I'm only saying it's better and wiser to look at the polynomial or look at the function first. Okay. Any questions? Okay, moving on. So let's look at an application in geometry now, from geometry if you want. So we have a triangle, and they're giving us the sides of the triangle. They say that this side is 13x squared minus 5x plus 7. They're telling us that this side is x minus 2, and they're saying that this side is 2x squared plus 10x minus 10. They want us to find the perimeter of this triangle. Let's take a moment and determine the perimeter. Anybody remembers the formula of the perimeter of a triangle or any geometric figure? What will be the perimeter of this geometric figure? What do we need to do? Anybody remembers the formula?
Add each side together.
That's it. So let's add them. 1 minute, please. So I'm just going to write them and wait for you to give me the answer. So I start anywhere, it doesn't matter. I start at this corner. 2x squared plus 10x minus 10 plus x minus 2 plus 13x squared minus 5x plus 7.
$15x squared plus 6x minus 5.
15x squared indeed. So these are the ones. So we have here 5 plus 1, 6. Very good. I agree. So this is done, and this is done. And negative 12 plus 7. It's negative
minus 5.
That's it. I completely agree. This is the perimeter, if you want to call it P of x, that's fine. The perimeter function of x. So please do not read this again. P times parentheses x. No, again, this is P of x. F of a. T of v. So P is the name of this expression, and x is the variable that you should expect to see inside. Okay, one more example before we move on to 5.2. So let's say 6x minus 13 minus 3x minus 6. A very simple example. Let's see what we have. What will be the first step, please, before you combine like terms? The first mandatory step.
Getting rid of the parentheses
Yes.
and multiplying everybody by -1.
Yes. So what should I write? Excellent.
Minus 3x plus 6.
Exactly. And now we combine like terms, and we always start with a degree. So we have 3x minus 19, and this is it. Oh, I'm sorry. I'm sorry. Of course, 7. Of course. Where's my whiteout? Oh, I got it. Of course, minus 7. Because this was positive, not negative. Very good. Thank you very much. Okay, moving on to, so please, the Learn 5.1 and the Practice 5.1 have to be finished. I'm only asking bare minimum, 70%. Why that is? If you fall behind, it will pile up on you and it will be difficult to catch up. So if you keep up with my requirements, you will never fall behind and you will never have difficulties in this class, please. So this is before class on Thursday. So now let's see what else we can accomplish today. So we are moving on to 5.2. This is a very important section. It deals with exponential rules and exponential notation. We have a little bit of experience with it. So let's talk about it. First of all, what it is, what is the exponential notation, and what are its rules. Every time we invent something, it comes with rules. So the exponential notation has a base and a power. This is called an exponential notation. This is called the base. This is called the power or exponent, whichever you prefer. They mean the same thing. Power or exponent. Now, let me refresh our memory one more time. A raised to 0 is 1, assuming that the base is not 0. Okay, please remember this. A base raised to 0 is always 1, except when in the case of 0 raised to 0. For this situation, you have to wait till calculus 1. This special case is discussed in Calc 1. It's not called undefined. It's called indeterminate. This is not for this class, but this is not called undefined. This is called undefined. 0 raised to 0 is indeterminate. 0 over 0 is also Calc 1. But any other number, any number except 0, 0 over 0 is Calc 1. It's not undefined. Any other number except 0, any other number divided by 0 is indeed called undefined. Okay. So we have several rules. So this was the first one, if you want. Here's the second one. These are the exponential rules. When we multiply exponential notations, like a raised to n multiplied by a raised to m. So for reference, so my N has 2 bubbles and my M has 3 bubbles. You can use any other notation if you'd like. It doesn't matter as long as you have not A, X and Y or something else. So when we multiply exponential notations, they have to have the same base. If they don't have the same base, we cannot use this rule. They must have the same base. How do I multiply them? I copy the base and add the exponents. And notice that we can go back and forth. If I multiply them, I copy the base and add the exponents. But I can recover the left-hand side, changing this into a product of 2 exponential notations with the same base, and one having power n and the other one having power m. This is the product rule. This is the product rule. So here's an example. 2 to the third times 2 to the fifth, or x to the third times x to the fourth. Can anyone give us the answers?
X to the third power plus 4.
Yes, x to the seventh. And the first one, 2
To the 8th power.
to the 8th power. Copy the base, add the exponents. So this is the product rule. Moving on. Rule number 3. Power rule. So here's the power rule. A raised to the nth power, but everything raised to the mth power. We copy the base. This time we multiply the exponents. N times m. And of course, we can go back and forth. So here's an example. 2 to the third, everything to the fifth. Or x squared, everything to the third. And then 2x squared y to the third, everything squared. So let's work on these 3. Can anyone give us the first one?
Two to the 15th.
That's it.
Sorry.
Can anyone give us the second one?
X to the 6th power.
That's it. Now please pay attention to the third one. How many factors do we see inside the grouping symbol?
2.
I see factor of 2, I see factor of x, and I see factor of y. All 3 factors have to be raised to this power. I cannot pick and choose. So first I have to raise 2 to the second power. Can anyone give us the answer?
4.
That's it. Then I have to copy x, use the power rule, and find the power or exponent.
Two. So 4.
Exactly. Copy the base. Use the power rule.
6.
Exactly. Very good. 2 squared is 4. X squared squared is x to the 4th. Y cubed squared is y to the 6th. And this is the final answer.
So why didn't y get a 2 in front of it? Because you multiplied the 2 in front of the x. Shouldn't it have been 2y?
So these are 3 factors. That's why I would identify them from the very beginning. This is not the distributive law. I'm not
You put it
distributing.
on the 2, that's a factor, and the y is a factor.
Yes, but I'm not distributing. These are 3 factors inside of one monomial, and I have to raise each factor to the corresponding power. What if I have a squared, b to the 3rd, c to the 4th, everything cubed? Do I distribute a squared to b and a squared to c? No, these are 3 factors. All 3 factors have to be raised to the 3rd power.
Well, you did say there's always a 1 in front of the factor, so isn't
Okay,
it,
1 to the 3rd power is still 1.
Okay.
A squared cubed, what do we get? A squared cubed, what do we get?
A to the 6th.
That's it. B cubed to the 3rd.
To the 9th.
That's it. C to the 4th cubed.
To the 12th.
That's it. So that's why I asked how many factors are there, because we need to get used to this. And we need to be able to analyze what's in here and how we get to the final answer. That's why I have another set of 3 factors. So the same thing here. They are connected by multiplication, but they cannot be multiplied. And these are factors, not the distributive law. I don't have an addition or subtraction here to distribute. So 2 squared is 4. X squared squared is x to the 4th. Y cubed squared is y to the 6th. Good. Next one. Power. Another power rule. Quotient. The quotient rule. A to the nth power over a to the mth power. Notice again, the base has to be the same. We copy the base, and this time we subtract. And it's always in this order. From the power of the numerator, we subtract the power of the denominator, not the other way around. Even if this one is bigger than that, it doesn't matter. You have to keep it as is. From the power of the numerator, we subtract the power of the denominator. So, for example, x to the 4th over x squared. X to the 3rd over x to the 3rd. And another example. 2x squared y to the 3rd over 4xy. Can anyone give us the first one?
Would be x squared.
Yes. Copy the base and subtract. Always in this order. From 4, I subtract 2 and I get 2. Good. Before you answer the second one, can anyone tell us what is 2 over 2?
One.
That's it. If we want to use this rule, the power of 2 is 1. The power of 2 is 1. We copy the base and subtract the exponents. From the exponent of the numerator, I subtract the exponent of the denominator, and I get 0. That is the reason why any number raised to 0 is 1. Now, there is no need here to write that 2 is not 0, sorry. Makes no sense. I don't need to write this. 2 is not 0. But here I have to, x not equal 0. Here I have to, x not equal 0. So here's my point. X to the 4th over x squared equals x squared only if x does not equal 0. Because if x is 0, I have 0 over 0, which is a situation that I don't know how to handle yet. So there is no need to say that 2 over 2 is 1 only when 2 is not 0, because 2 is never 0. But this is a variable, and variables can take different values. So x to the 4th over x squared is x squared indeed, but only if the denominator, which is x, is not 0.